Feindkontakt. 11 Uhr tief. Ich greife an.
Bereits in 1940 of Torrizo Fentiunci by Sportrat or Convict Vino Pronormarchik Quaklinde by de 6.
The Messerschmitt Bf 109, seen here with its Daimler-Benz 605 engine exposed, was the Luftwaffe's primary workhorse throughout the war.
The Bf-109's solid design ensured its deployment across all German theaters of operation.
Hello and welcome. This is a Blue Paw print production.
Here we see the all-metal construction. The defining feature of the wing is its single-spar structure, visible here in teal.
On the external surfaces, you'll notice the meticulous use of flush countersunk rivets. This design ensures a smooth
This X-ray visualization reveals the massive DB605 V12 engine. Note the intricate placement of the synchro.
This X-ray view highlights the critical cockpit area, along with the essential connection points for the wing spars. The X-ray visualization clearly highlights the structure of the L-shaped internal tank. Note the reinforced typical all-metal tail with fabric-covered controls.
The elevator trim was the only dethinning controlled by the pilot.
During high-speed dives, trim control is essential for maintaining stability and preventing structural failure.
Demonstrating the Bf-109's simple wing installation and removal. The ground crew could swap out a damaged panel remarkably quickly.
As you can see, the hydraulically operated flaps at both the front and rear of the radiator deploy smoothly, controlled by these precision linkages.
The flaps are under automatic control by the thermostat, but can be manually controlled for landing.
The pilot uses the manual flap extension set system to increase drag during the landing approach.
Allied pilots quickly learned that the large radiators beneath the wings were the Messerschmitt's weak spot.
The ability to shut off the damaged radiator, if detected in time, was crucial for survival.
Asymmetric slat opening could disturb aiming during dogfights. The slats provide improved low-speed handling and significantly better stalling characteristics, crucial for both combat and landing.
The typical intercept altitude against bombers was around 26,000 feet.
As we climb, the mandatory oxygen system must be activated. Turn the valve and monitor the flow rate here.
Approaching the combat zone, the pilots activated their weaponry. The twin 13mm machine guns mounted above the engine were now ready to fire.
Designed for optimal firepower, the MG-151 cannon was mounted to fire directly through the propeller hub.
Adjusting the convergence of the MG-131s was a precise job, ensuring the rounds would impact the target at the optimal distance. The electrical charging of the weapons is critical. As the hatches open, the blue glow indicates the system is primed and ready to fire.
The Messerschmitt could carry various external stores. This one is equipped with a 300-liter drop tank.
The heavy ordnance severely impacts maneuverability, causing a noticeable performance drop.
The Luftwaffe typically employed the Schwarm, or group of 4, often broken down into 2 Rotten, or pairs.
We must exploit the gap in their escort fighters. Hit the bombers hard and fast, then egress to the southeast.
Against heavy escort fighters, the quick pass was the only viable tactic, utilizing the Bf-109's superior speed and climb rate.
That approach the Daguri. The key here is the speed of this impeller. Spinning at thousands of RPMs, it forces out pressurized air.
The supercharger provides a significant power boost, but pushing it too far risks dangerous overpressurization.
The automatic pitch control significantly reduces the pilot's workload.
This is the oil cooler radiator, situated at the front of the engine cowl. Its primary function is to dissipate the heat.
Wartime regulations required the intricate Daimler-Benz engine to be completely overhauled every 100 hours of flight time.
The aircraft suffered from a zig tie.
As we move deeper, we see the high-pressure pumps in action. This advanced fuel injection system utilizes these specialized components.
External tank increases operational range to 280 miles, flight of 450 kilometers.
Fuel transfer from the drop tank is initiated by injecting pressurized air. The gauge confirms the pressure is sufficient for the transfer sequence.
This right here is the primary flow indicator. The speed and intensity of the blue plasma dictate the fuel pressure to the reactor.
As you can see, the main gear utilizes a powerful hydraulic system to pivot downwards, finally locking into place with a solid clunk.
This Messerschmitt's tail wheel, glowing with an unusual blue energy, was famously non-retractable, a design choice that saved weight.
It lacked an emergency retraction mechanism, relying instead on its mechanical lowering capability. The emergency lowering procedure initiates the freefall sequence. The gear slowly descends, relying solely on gravity.
The narrow gear stance of the Messerschmitt was a design flaw, notoriously causing tipovers and contributing to a 10% loss rate.
The pilot reported the landing gear held, but major repairs or perhaps a wing replacement might still be necessary after that stress.
The Messerschmitt's design allowed for relatively easy wing removal, a significant convenience for road transport. In stark contrast to the spacious American designs, this cockpit prioritizes a centralized, compact layout, making every inch count.
Here we have the primer pump, the main throttle control, and down here the tailwheel lock.
The sequential illumination confirms the inertial navigation system is aligning. All primary flight displays are now active and reading green.
Taxiing the Bf-109 requires careful use of the brakes. The pilot applies pressure to the rudder pedals, turning the aircraft efficiently on the tarmac.
Due to the thick fog, the pilot must perform S-turns to maintain situational awareness on the taxiway.
The boost pressure is now reaching the takeoff power setting of 1.4 ATA.
The plane swings right and left, requiring rudder correction.
At 105 miles per hour, the formidable Bf-109 achieves rotation and liftoff.
Immediately after liftoff, the pilot applies the brakes to halt the spinning wheels. He then engages the retraction mechanism, pulling the gear up into the fuselage.
With a staggering 34,000 units built, the Bf-109 holds the record as one of history's most significant fighter aircraft.
The Bf-109 G6 was a versatile fighter, operating in diverse environments, from the frozen landscapes of the Arctic.
The Messerschmitt Bf-109 G6
credited with over 30,000 enemy aircraft shot down. The Daimler-Benz DB605 engine, seen here in detail, provided the F109 G6 with